There is something sitting underneath millions of homes right now. Something wet. Something growing. Something that wasn't supposed to be there. And something that, for a very long time, simply wasn't. Walk into the average American basement today, and there's a decent chance you'll find water stains creeping up the walls, a faint smell you can't quite place, maybe a dehumidifier running constantly just to keep the air breathable. Homeowners chalk it up to bad luck, or bad weather, or just the way basements are. Contractors show up, quote them thousands of dollars in waterproofing systems, interior drains, sump pumps, vapor barriers, and the cycle starts over again. But here's what nobody is telling you. This wasn't always normal. Go back far enough, before World War II, before the post-war housing boom, before the era of fast construction and standardized building codes, and a wet basement was considered a failure, not an inconvenience, not a maintenance issue, a genuine failure of craft, something a mason would have been embarrassed by. Something that simply should not have happened if the work was done correctly. Because the work, when done correctly, didn't let water in. The wet basement epidemic is one of the most expensive and least discussed problems in residential housing. Tens of millions of homes across North America deal with moisture intrusion every single year. The mold that follows costs families their health. The structural damage costs them their equity. The remediation industry built up around this problem generates billions of dollars annually, and almost none of that money is spent asking the one question that actually matters. Why did the old foundations stay dry? Not with sump pumps, not with interior drainage channels, not with any of the products being sold to you right now at your local home improvement store. They stayed dry because of how they were built, because of a specific technique, a specific understanding of how water moves through soil and stone, that was quietly abandoned around 1962. And it all comes down to one angled stone. When renovators started tearing into century-old foundations, not to fix them, but to expand them, to finish basements, to run new mechanicals through walls that had stood for 100 years without complaint, they kept finding something they didn't expect. Something that slowed the work down. Something that made the crew stop and look at each other. A stone, set at an angle, not sitting flat the way every other stone in the wall was sitting, not stacked horizontally the way you'd expect. Tilted. Deliberately, precisely tilted, usually at the very base of the foundation wall, right at the point where the footing met the earth. Sometimes it was limestone, sometimes granite, sometimes a dense local fieldstone that the original mason would have selected by hand from whatever the land offered. But regardless of the material, the positioning was the same. Intentional. Repeated. Consistent across foundations built decades apart, by different craftsmen, in different regions, using different materials. The renovators who noticed it mostly just worked around it, pulled it out if it was in the way, didn't write it down, didn't ask questions. It looked like an irregularity, like maybe the original mason had made a small mistake and compensated for it, or grabbed the wrong stone at the wrong moment and decided to make it work. That's the generous interpretation. The less generous one is that nobody was paying close enough attention to understand what they were looking at. But some people did pay attention. Historic preservation specialists, architectural historians, a small number of structural engineers who made it their business to understand why old buildings behaved differently than new ones. And when they started comparing notes, when they started cataloging what they'd seen across dozens and then hundreds of pre-war foundations, the pattern became impossible to ignore. This wasn't a mistake. This wasn't a compensation. This was a feature. A deliberate, load-bearing, water-managing feature that appeared in foundations across New England, across the upper Midwest, across eastern Canada, across every climate zone where groundwater and freeze-thaw cycles made wet basements a genuine structural threat. The masons who built these walls weren't working from the same blueprints. They weren't trained in the same schools. Many of them were immigrants who brought their knowledge from Europe, from traditions of stone construction that went back centuries before anyone in North America had poured a single footing. And yet they kept arriving at the same solution, the same angled stone, in the same position, doing the same job. One researcher who documented this pattern described it as finding the same word in 20 different languages. The specific form was different each time. The underlying meaning was identical. These builders understood something about water, about the way water moves under pressure through soil, about the way it finds and exploits any horizontal surface it can travel along. That modern construction science had effectively unlearned, or more precisely, had replaced with products and systems that address the symptom while completely ignoring the cause. The stone wasn't decorative. It wasn't structural in the way a keystone is structural, holding an arch together through compression. Its job was hydraulic. Its job was to intercept water at the most dangerous point in the entire foundation assembly, the junction between the vertical wall and the horizontal footing, and redirect it before it could find its way inward. One stone, one angle, one decision made at the very beginning of the build that protected everything that came after it. The question worth asking is how they knew to do it. Because the answer to that question reveals something remarkable about what we've lost. To understand how pre-industrial masons arrived at this solution, you have to stop thinking about construction the way we think about it now. We think about construction as a problem of engineering. They thought about it as a problem of observation. These were men who had no waterproofing membranes, no hydraulic cement, no sump pumps, no French drains, no dimple board, no crystalline admixtures. They had stone, they had lime, they had sand, and they had time. Enormous amounts of time. Because the buildings they were raising weren't meant to last a generation. They were meant to last forever. And when your building has to last forever, you become extraordinarily attentive to the ways that forever can go wrong. Water was the thing that went wrong. It was always water. A mason who had watched enough old foundations fail, and these men had watched many, understood something that took modern science centuries to formally describe. Water doesn't just fall, it moves, it travels. It finds pathways through soil the way a river finds pathways through rock. Not by forcing its way through, but by following whatever gradient gravity has already laid out for it. And the ground around any foundation is full of those gradients. Every horizontal surface is an invitation. Every flat ledge is a runway. The pre-industrial mason understood this not because he'd read about hydrostatic pressure or capillary action. He understood it because he dug up enough failed foundations to see what water had actually done inside them. He'd seen the staining. He'd seen where the lime had dissolved. He'd run his hand along the base of a footing that had been in the ground for 50 years and felt exactly where the damage was concentrated. Right there at that junction. Right at the place where the wall met the floor. That horizontal ledge where water pooled, sat, pressed, and eventually won. So the solution wasn't theoretical. It was empirical. It came from watching, failing, adjusting, and watching again over generations. A craft knowledge that was passed from master to apprentice, not through textbooks, but through demonstration. You did it this way. You angled it here. You held the stone like this and set it like that, and here is why. Here is the foundation we dug up last spring. Here is where it failed. And here is how our buildings haven't failed, because we do not give the water a place to rest. There's something almost ecological about how these masons thought. They understood their building as a thing embedded in an environment, not separate from it. The ground wasn't just a platform to build on. It was an active system that was constantly moving moisture, constantly seeking equilibrium, constantly probing whatever you'd put into it for weaknesses. Your foundation wasn't fighting the ground, it was negotiating with it. And the terms of that negotiation had to account for water at every single point where water might appear. The angled capstone at the footing joint was one of the most important terms in that negotiation. Because that junction, that right angle where vertical becomes horizontal, is precisely the place where the negotiation breaks down if you let it. Water arriving at the base of a wall needs somewhere to go. If you give it an angled surface, it goes down and away, back into the drainage layer, back into the soil, back out of the equation. If you give it a flat surface, it stays. It waits. And given enough time and enough pressure from the saturated soil behind the wall, it finds the crack that will eventually be there. Because there is always eventually a crack. The old masons knew this. They built accordingly. And for centuries, it worked. Now here's where it gets interesting. Because what those masons were doing wasn't superstition, and it wasn't art. It was physics. Elegant, simple, and completely indifferent to whether you understand it or not. Water under pressure is not patient. It doesn't knock. It doesn't wait for an invitation. It probes. Constantly. And the direction it moves is always toward the path of least resistance. That's not a metaphor. That's the actual mechanism. Hydrostatic pressure, the weight of water-saturated soil pressing against your foundation wall, is pushing inward at every moment the ground stays wet, which, in most climates, is most of the time. Now think about what happens at the footing joint. That's the horizontal ledge at the base of your foundation wall, where the vertical surface transitions to the flat footing below. In a modern poured concrete foundation, that joint is a right angle, 90 degrees, clean, square, precise. It looks correct. It looks stable. And it is, structurally. But structurally isn't the only thing a foundation needs to be. That right angle creates a collection point. Water running down the face of the wall, whether it's seeping through the porous concrete or arriving from the soil side, hits that flat ledge and stops. It pools. It sits. And pooling water at a foundation joint is not a minor inconvenience. It's a countdown. Here's the science. Water expands when it freezes, roughly 9% by volume. In a climate with freeze-thaw cycles, that pooled water at the footing joint freezes, expands, contracts, freezes again. Each cycle opens the joint a little wider. Each cycle drives water a little deeper. The crack that wasn't there in year 1 is there in year 7. And once it's there, the pooling accelerates. The damage compounds. The basement gets wet. Now tilt that surface. Give it even 1 degree of slope, just 1, angled down and away from the wall, toward the drainage layer. And the physics change entirely. Water arriving at that surface doesn't stop. It keeps moving. Gravity takes it. It sheds off the joint, finds the gravel below, and moves away from the structure. The collection point disappears. The countdown never starts. 1 degree. That's not a dramatic intervention. You wouldn't notice it visually. You wouldn't feel it if you ran your hand across it. But water notices it. Water notices everything. The pre-industrial masons who cut those angled capstones weren't doing it because it looked elegant. They were doing it because they'd watched what happened over time when they didn't. They'd seen the pooling. They'd seen the cracking. They'd torn out enough failed foundations to understand where the failure always began. And they'd solved for it with something as simple as a chisel angle and an understanding of slope. The modern term for this is positive drainage geometry. Civil engineers use it in designing roads, bridges, parking structures, any horizontal surface where water accumulation creates a long-term liability. The principle is identical. Slope the surface. Shed the water. Remove the collection point before it becomes a failure point. The old masons didn't have the terminology. They had the outcome. And for centuries, the outcome was the same. Dry basements, intact foundations, walls that were still standing long after the men who built them were gone. 1 angled stone at the footing joint. Not magic, not mystery, just geometry working with gravity instead of against it. The question isn't why it worked. The question is why we ever stopped doing it. And that question has an answer, a specific one, with a specific year attached to it, 1962. That's when the shift happened, not overnight. Not all at once. But that's the year the industry crossed a threshold it hasn't come back from. To understand why, you have to understand what was happening in American construction at that exact moment in history. The post-war housing boom was still running at full speed. Suburbs were expanding faster than the country had ever built before. Developers needed homes up quickly, thousands of them, tens of thousands. The pressure wasn't on quality, it was on pace, on cost per unit, on how fast you could break ground, pour concrete, frame, and move to the next lot. Skilled masons, the kind who understood footing geometry, who'd apprenticed under someone who actually knew what that angled capstone was doing. Those men were becoming expensive, becoming slow, becoming, in the language of the era, inefficient. And in 1962, two things converged that made it easy to leave them behind. The first was the widespread adoption of poured concrete foundation systems at scale. Pre-mixed, truck-delivered, poured into temporary forms. Fast, standardized, and, critically, designed around a completely different assumption about waterproofing. Instead of shedding water away from the structure through geometry, poured concrete foundations were designed to resist water through mass and coating. The assumption was that if you sealed the exterior of the wall and the footing with tar or membrane products, you didn't need slope. You didn't need angle. You just needed thickness and chemistry. The second thing was the publication of updated residential construction guidelines that, for the first time, codified this approach nationally. The angled capstone at the footing joint wasn't mentioned. It wasn't banned. It was simply absent, left out. And in construction, what isn't written into the standard doesn't get taught. What doesn't get taught doesn't get built. Within a decade, an entire generation of contractors had come up through the trade without ever seeing the technique done, without ever knowing there was a technique to see. The knowledge didn't get discredited. It didn't lose an argument. It just quietly disappeared from the conversation. The way things disappear when they stop being passed down. The men who remembered it were older by then. Many of them retired through the 60s and 70s. Some tried to explain it. Most were told the new methods were better, more modern, more reliable. They weren't. What the industry had traded was a passive, permanent, geometry-based drainage solution for an active, maintenance-dependent, material-based one. Coatings crack, membranes fail, sealants degrade, slope doesn't, angle doesn't, gravity doesn't change its mind. The builders of 1962 weren't negligent. They were optimistic. They believed the new materials would outperform the old geometry. 60 years of wet basements later, we have the data to know whether they were right. And the data is not kind. The United States alone spends somewhere between $9 and $14 billion every single year on water damage related to basement and foundation failures. That number doesn't come from a fringe study or an obscure report. It comes from insurance actuaries, from restoration contractors, from the companies that sell the dehumidifiers and the sump pumps and the waterproofing systems that get installed after the problem has already arrived. That number is what the industry costs after the geometry got removed. That's the price tag on forgetting. But the money is almost the smaller part of it. Mold is the part that doesn't show up cleanly in the figures. Mold grows where moisture persists. And moisture persists in basements that were never built to move water away from the footing joint. It settles into framing. It climbs up wall cavities. It establishes itself inside structures that look completely fine from the outside and from the finished interior. Families live in those houses for years without knowing. Children grow up in them. The mold is invisible until it isn't, and by the time it becomes visible, the remediation cost has often grown larger than the original construction cost of the affected space. There are millions of homes in this country built between 1962 and the mid-1980s, sitting on foundations that are handling water the hard way. with effort, with material, with systems that require maintenance, replacement, and eventual failure. The sump pump that runs every time it rains isn't a sign that everything is working. It's a sign that the geometry never did its job in the first place. A foundation that handles water correctly doesn't need a sump pump cycling on 3 times an hour during a rainstorm. It redirects water before that water ever becomes a problem. The coating on the exterior wall of a modern basement has a service life. 15 years is generous for most of them. 20 if the conditions are ideal and the application was perfect. Then it begins to crack at the joints, at the corners, at every point where the wall moves even fractionally with temperature and settling. And water is patient. Water finds every crack. Water has been finding cracks for longer than there have been builders trying to stop it. The angled stone didn't crack. It didn't degrade. It didn't need a service interval. It just sat there at the footing joint, tilted at the correct angle, doing its job year after year, decade after decade, redirecting water by the most reliable mechanism ever discovered. Gravity, which has never once failed to show up for work. But not everyone forgot. There are masons still working today, mostly older men, mostly in regions where the building traditions ran deep and the apprenticeships lasted long enough to actually transfer knowledge instead of just certifying completion, who never stopped placing that stone. You find them in parts of rural New England, in certain pockets of the mid-Atlantic states, in the hill country of Central Europe, where the same families have been laying foundations on the same slopes for 200 years. Ask them why they do it, and most of them can't give you a textbook answer. They'll say something like, "That's how it was shown to me," or "The water has to have somewhere to go that isn't inside." They learned it by watching, by doing it wrong once and being corrected, by seeing what happened to a neighbor's foundation that skipped the step versus the one that didn't. The knowledge survived not because it was written down somewhere. It survived because a handful of craftsmen valued the outcome more than the shortcut. They weren't trying to preserve ancient technique for its own sake. They were just trying to build something that didn't fail. And it turned out those two things were exactly the same goal. The good news is, you don't need a 200-year apprenticeship to use this. If you're working with a contractor on a new foundation, ask specifically about the capstone angle at the footing-to-wall transition. That's the conversation starter. A mason who knows what you're talking about will tell you immediately. One who doesn't is worth noting. The principle translates cleanly to modern materials, poured concrete, block, even insulated forms, because the physics hasn't changed. Water still moves downhill. A slight outward pitch at that critical juncture still redirects it away from the wall cavity. Old technique, new pour, same result. A basement that stays dry without asking you to fight it every spring. If this changed how you think about foundations, pass it on. Send it to someone who's planning a build, someone fighting a wet basement right now, someone who just bought an old house and doesn't understand why it stays dry while the neighbor's floods every March. This knowledge didn't disappear because it stopped working. It disappeared because nobody kept saying it out loud. That's the only reason any useful thing gets lost. So say it out loud. Share this. Because somewhere right now, a foundation is being poured without that angle, and nobody on that job site is going to stop and ask why.